Good afternoon, math classes. Today we are going to be looking at our corrections for our homework from last night, which was on page 176 in our math book. So we had 4 problems to do, numbers 1, 2, 3, and 4 on page 176. We're going to start out by talking about number 1, which was a situation in which the ratio of oxygen atoms to sulfur atoms in sulfur dioxide is always the same. The table shows the number of atoms in different quantities of sulfur dioxide. Complete the table. So when we know from the table that when we have 6 atoms of sulfur, we have 12 atoms of oxygen to create sulfur dioxide. I'm sure, little language arts lesson here, you guys recognize the prefix di means 2. So it makes sense that we would have 1 oxygen of sulfur for every 2 atoms of oxygen. 1 atom of sulfur for every 2 atoms of oxygen. That's what creates sulfur dioxide. You guys might talk about this in your science classes at some point this year. Maybe you already are. So let's take a look at our table. We know that when we have 6 atoms of sulfur, we have 12 atoms of oxygen. So we always want to see if there's some kind of multiplicative relationship that we can notice. And I noticed that I can do 6 times 2 to get 12. So I'm just going to write that over here so I remember times 2 when you go from sulfur to oxygen. So then if I do that same thing to 9 atoms of sulfur, what's 9 times 2? That would be 18. And then 21 times 2 would be 42. And then now I know the oxygen and I want to figure out the sulfur. So from sulfur to oxygen I multiply by 2, but in order to go from oxygen to sulfur I have to do the inverse of that, which is to divide by 2. So 54 divided by 2 I know is 27. And just a quick reminder that you guys are allowed to use your calculators for this whole entire unit. So go ahead and put those calculators to use. Now it's asking us what are the equivalent ratios shown in the table. I'm just going to look back up here and see how they want us to write the ratio. They said oxygen atoms to sulfur atoms. So let's put oxygen on the top of the fraction and sulfur on the bottom because they say oxygen first. So let's do, there's one ratio of 12 to 6, oxygen to sulfur. And then we have this one of 18 to 9. And then this ratio here of 42 to 21, and then this ratio here of 54 to 27. So those would be the equivalent ratios that are shown in the table. Now we're going to use that information and put that into this graph over here. We have sulfur along the bottom and oxygen along the side. So when sulfur is 6, oxygen is 12. Let's start with that data point right there. So we'll go over to sulfur 6, oxygen 12, and we'll put a point right there in the graph. Then we have sulfur 9, oxygen 18. So here's 9 and 18. They would be kind of halfway between, 9 is halfway between 6 and 12. It's that hash mark right there. And then the 18 would be halfway between the 12 and the 24, so that hash mark right there. Then we have 21 and 42. So we go over to sulfur 21, right in between the 18 and 24. And we go up to the 42, which is right in between the 36 and the 48, and we put our point right up there in the graph. And then finally we have 27 and 54. Here's 27. Follow that all the way up to the top until we get to that 54 mark. And that would be our graph for sulfur atoms to oxygen atoms. All right, now let's go on to number 3. Stickers are made with the same ratio of width to length. A sticker 2 inches wide has a length of 4 inches. Complete the table. So first of all, we know that if the width is 2 inches wide, it says that's width, then we have a length of 4 inches. So let's put that 4 underneath the 2 because that's the ratio that they're telling us in the situation in the little paragraph here. Now, what's the multiplicative relationship between 2 and 4? Well, I know I can do 2 times 2 equals 4. So everything here is going to be similar to our first table in a graph, and we're going to do times 2. So 4 times 2 is 8, 7 times 2 is 14, and then of course here we know the length. We have to divide by 2. We have to do the inverse of times 2, which is divide by 2 to get 8. So 16 and we have 8 as the width. All right. Now, what are the equivalent ratios? They said ratio of width to length. So we're going to put width first here, or on the top. So width is 2, length is 4. When the width is 4, the length is 8. When the width is 7, the length is 14. And when the width is 8, the length is 16. All right, then we are going to graph these. So again, when the width is 2, the length is 4. When the width is 4, the length is 8. When the width is 7, which is in between the 6 and the 8, the length is 14, so that would be right there. And then when the width is 8, the length is 16. All right, so that would be how we would graph that one.